If you could build the perfect Linux PC and you had the creator of Linux sitting next to you, what would you choose? More RGB, the fastest gaming GPU, or something completely different? This isn't just another PC build. This is a build shaped by someone who understands Linux from the inside out, not just as a user, but as the person who started it all. When Linus Tech Tips sits down with Linus Torvalds to build a Linux PC, the conversation instantly shifts. It's no longer just about specs. It's about philosophy, stability, long-term reliability, and how hardware choices actually affect real-world Linux development. Because here's something most people don't think about. The perfect Linux PC doesn't look the same as the perfect gaming PC. Gamers chase maximum frame rates. Creators chase GPU acceleration. But kernel developers, they chase stability, predictability, and clean hardware support. One of the first topics that comes up in a build like this is memory, specifically ECC memory. Now, if you're not deep into hardware, ECC might sound like some obscure enterprise feature. But ECC, or area correcting code memory, exists for one main reason: data integrity. It detects and corrects small memory errors before they cause crashes or corruption. For most home users, a random bit flip in RAM might never be noticed. But when you're compiling the Linux kernel, managing huge code bases, or maintaining software that powers millions of servers worldwide, even rare errors matter. That's where the discussion gets interesting. Do you prioritize consumer-level performance? Or do you prioritize server-grade reliability? That tension between performance and stability defines this entire build. Then there's storage. Modern NVMe drives are incredibly fast, but speed isn't the only question. Reliability, endurance, and long-term consistency matter just as much, especially when dealing with massive source trees, virtual machines, and development environments. And here's something that might surprise people. This build isn't about extremes. It's not about stuffing in the most expensive parts just to flex numbers on a benchmark chart. It's about choosing parts that work beautifully with Linux drivers. Parts that don't require constant troubleshooting. That says a lot about open source philosophy. Linux development thrives on transparency and compatibility. Hardware that plays nicely with open drivers and doesn't require proprietary tricks fits that mindset much better than flashy but problematic components. Another interesting layer in this collaboration is the discussion around AI. AI-assisted coding tools are becoming more common. Some developers love them, others are cautious. So when the conversation shifts toward AI in development, it opens up a bigger question. Does AI make coding better? Or does it change how developers think about software entirely? The idea of pairing traditional kernel development with modern AI tools creates a fascinating contrast. Old-school engineering discipline meeting new automation trends, and that balance reflects something deeper. Linux itself has survived decades of technological shifts. It has adapted to new hardware architectures, cloud computing, mobile devices, and now AI workloads. So building a Linux PC today isn't just about compiling code. It's about preparing for what computing looks like tomorrow. What's even more compelling are the unexpected moments, the small anecdotes. Stories from early Linux development, reflections on decisions that shape the kernel, casual insights that don't show up in formal interviews. Because beyond the specs and philosophies, there's a human side to this build. It's one thing to read about open source ideals online. It's another to hear firsthand how those values influence real hardware decisions. At its core, This PC isn't meant to impress with flashy visuals. It's meant to work quietly, efficiently, reliably, and in many ways that might be the most Linux thing possible. But we're just getting started. Because once the parts are chosen, the real conversation begins about what truly makes a system perfect for Linux development. Once the main parts are on the table, the conversation naturally shifts from hardware to workflow. Because here's the thing. Building the perfect Linux PC isn't just about what's inside the case. It's about how that hardware supports the way Linux is actually developed. Take the CPU, for example. For a gaming build, the focus might be high boost clocks and single-core performance. But for Linux development, especially kernel work, multi-core performance matters a lot. Compiling large code bases can fully utilize many cores at once. Faster compile times don't just save minutes, they save hours over the course of weeks and months. That adds up. But raw speed isn't everything. Thermal stability is just as important. A processor that runs consistently at safe temperatures under heavy load is more valuable than one that briefly spikes to high numbers. Development machines are tools. They need to perform predictably, day after day, not just during benchmark runs. Then there's ECC memory again, and this is where the philosophy becomes clear. Most consumers don't worry about memory errors. They're rare. But rare doesn't mean impossible. When you're building an operating system that runs mission-critical infrastructure worldwide, even rare errors deserve attention. Choosing ECC isn't about fear, it's about discipline. It reflects a mindset that values correctness over convenience. That mindset is deeply connected to how Linux has been developed for decades. Careful review, peer collaboration, and constant attention to stability. Now let's talk about storage in more detail. Fast NVMe drives drastically improve responsiveness, especially when building software. But development environments also generate a lot of writes. That raises questions about endurance and long-term durability. You don't just want speed, you want consistency. Some developers even prefer separating their storage, one drive for the operating system, another for projects, maybe another for testing environments. That separation reduces risk and keeps workflows clean. It's not flashy, it's practical. Graphics are another interesting topic in this build. A Linux-focused system doesn't necessarily need the biggest GPU available. Unless you're doing GPU-accelerated workloads, compiling code relies heavily on CPU and memory. But driver support still matters. Linux has made huge progress with graphics drivers over the years. Still, hardware compatibility remains an important factor. Choosing a GPU that works smoothly with Linux drivers without constant tweaking saves time and frustration. And that's the recurring theme. Time saved on troubleshooting equals more time spent building. Another layer of the discussion dives into open source philosophy itself. Linux development isn't controlled by one company. It's shaped by contributors worldwide. That decentralized model encourages flexibility and experimentation. It also means hardware decisions aren't dictated by marketing partnerships. In this kind of build, the question isn't what's trending, it's what works best. That mindset also influences thoughts about AI and coding. AI tools are becoming part of many developers' workflows. Some see them as productivity boosters. Others worry they could change how developers think about problem solving. When you've spent decades writing and reviewing code manually, you develop instincts. You understand edge cases. You see patterns. AI tools can assist, but they don't replace deep understanding. So integrating AI into a Linux development machine becomes less about hype and more about balance. Use it where it helps, ignore it where it doesn't. That balanced thinking shows up everywhere in this build. There's no obsession with extremes, no dramatic overkill. It's just careful selection aimed at creating a system that feels smooth, stable, and dependable. And that's something people often misunderstand about Linux culture. It's not anti-performance. It's pro-efficiency. Efficiency in hardware, efficiency in software, efficiency in thought. By this point, the build starts to feel less like a tech showcase and more like a reflection of values. Reliability over flash, consistency over hype, control over convenience. But we're not done yet. Because once the hardware conversation settles, the bigger question remains. What actually makes a Linux PC perfect? And the answer might not be what you expect. So what actually makes a Linux PC perfect? It turns out, it's not about having the absolute best parts money can buy. It's about balance. A perfect Linux PC is one where the hardware disappears, where you don't think about drivers, you don't fight compatibility issues, you don't worry about random instability. The system simply does what you ask it to do quickly, reliably, and quietly. That idea fits Linux perfectly. Linux was never about flashy presentations or dramatic launches. It evolved steadily, carefully, iteratively, and the ideal Linux machine reflects that same philosophy. One interesting takeaway from this build is how little ego plays into it. There's no need to chase the highest wattage power supply just in case. No need to double the GPU budget for bragging rights. No need to push components beyond their stable limits. Instead, the focus stays on clean airflow, stable voltages, reliable cooling, and components known to behave well under Linux. That's maturity. Another surprising detail is how much the conversation drifts into long-term thinking. Hardware today must support software tomorrow. Linux isn't static. Kernel evolves constantly. New hardware standards appear. AI workloads grow. Virtualization becomes more common. So building a Linux development machine isn't just about current needs. It's about flexibility. That's where things like extra memory headroom, fast storage expansion, and strong CPU multi-core scaling matter. It's not about overbuilding. It's about future-proofing responsibly. And then there's something deeper, something less technical. The perfect Linux PC isn't just about the machine. It's about ownership. When you build your own system and run Linux on it, you control the stack from hardware to kernel. You understand what's inside, you decide how it behaves. You're not locked into a corporate ecosystem dictating updates or feature changes. That sense of ownership is powerful. It's why so many Linux users build their own PCs in the first place. This collaboration highlights something important. Linux thrives in environments where curiosity drives decisions. Instead of asking what's the most expensive, the better question becomes what makes sense. And that shift in thinking changes everything. The discussions about ECC memory, storage reliability, and AI tools aren't random technical tangents. They reflect a consistent mindset, thoughtful engineering over hype-driven upgrades. Even the casual anecdotes, stories from early kernel development, reflections on how hardware trends have changed over the decades, reinforce that mindset. Technology moves fast, philosophies endure. And the philosophy behind Linux has always been about openness, stability, and continuous improvement. So in the end, the perfect Linux PC isn't defined by RGB lighting or benchmark charts. It's defined by LCD stability under pressure hardware that respects open drivers performance that serves workflow, not ego flexibility for future innovation. And maybe most importantly, A system that gets out of your way so you can build what matters. That's what makes this build so compelling. It's not just a collaboration between two well-known names. It's a reflection of how software and hardware philosophies intersect. You don't need to be the creator of Linux to appreciate that mindset. You just need to ask yourself one simple question. When you build your next PC, are you chasing numbers? Or are you building something that truly fits how you work? Because sometimes the perfect system isn't the loudest one. It's the one that quietly does its job every single day.